All right, so for number 1, it says Trista, whose house is at 3-6. Where is 3-6 on here? Which
3-6 is at T.
Thank you. Where's 3-6? Is it this dot?
Yes,
this dot?
that's the first dot.
Over 3, up 6. This is Trista's house, right? Let's see. And then we've got Laura, who lives at 8-2. Is that the top one or the bottom one? Bottom. So this is Laura's house. And then we've got Diana's house is at 8-6, which has to be the last one. We need to figure out who lives farther away, Trista or Laura.
Well,
so this is Trista 3-8, 6-8. I have that wrong. Sorry. 8-6-6. Okay. We gotta figure out the distance between the points. How do we do that? Down?
So line them up like this. Take the 3, and then the 3, 8, and then you put the 8 and 6 at the bottom. And then you just cross out the 2 that are the 6, and then you add the ones that either add or subtract.
You're on the right track. You subtract on that one. You are on the right track, but in this case, we don't have to do that because we have the picture, right?
Oh yeah.
So
you can just look in it.
we can just count, right? So from 3-8 to 3-6, we have 1, 2, 3, 4, 5. Because 3 to 8. So this one is 5 blocks. Let's call it blocks. Let's say they live blocks apart. And then from 2 to 6, we've got 1, 2, 3, 4. 4 blocks. So who lives farther away, Trista or Laura? Trista. Or Laura. Charlie?
I told you, one of the numbers in the wrong spot.
How so? Oh.
They're both on the same one, but both the 8 are on the opposite side.
No, they're not.
Well, they're closer to each other.
Are you talking about these two?
Yeah.
So this one we went over 3. That's where we get our 3. Oh, this is supposed to be a 6. That's why. Sorry. That's all that matters. They're on the same line. So there you go. Better? Okay. So Trista lives farther away by 1 block. For number 2, is the dependent variable your x or your y?
X.
It's your Y.
It's your y. The x, so if we think about a table, you can change your x value to be anything you want. It could be negative 200, 0, 86, 4.5. Your x value can be anything you want if you have an equation. Y equals 3 times x, right? You can put whatever for x. Whatever you put in for x, doesn't matter. But whatever you get out depends on whatever you put in for x. So it's your dependent variable.
So Y?
So y is your dependent. What does that make x?
X is your independent.
Independent variable. Y is your dependent.
Isn't it always like that though?
It will always be like that. Whatever you get for y depends on what you put in for x. Remember that function machine that I drew?
Yeah, the equation machine.
Yeah. You put in an x value, and your y value that comes out depends on what happens inside your function machine. All right? Okay. Our next one, we have what, negative 3 plus 7? Right?
Yeah.
Where do I start here then?
You would have to start. Wait, no, it's negative 4 plus
Is
7.
it? Are you sure? You are correct. It was negative 4 plus 7. Okay.
So, okay.
Negative 4. Where do I start?
You have to start by putting the 4 on top of the 7. Because
Well, we're using our number line though. How do I do it with a number line?
it's like you have to go backwards. Like
We're adding 7. Where do I start?
Go right.
Where do I start?
Start at
Negative 4.
7 times.
If I'm adding 7, you go to the right 7. 1, 2, 3, 4, 5, 6, 7. Where do you end up? What's your answer?
3.
3.
I thought it was where you had to. Wait, what if? What you had the negative seven, what is, because what I did was, I did negative 4.7, and then I added negative 4, 7 tenths, which I got negative 1.
That would be if you were adding in negative 7.
Yeah, and that's what we here in the negative 7.
That would be negative 3.
11,
Negative 3.
right?
The only way that you would get negative 11 is if you took negative 4 plus negative 7 because you're going backwards 7.
I thought you could have the negative on the top of the
No, if you were to do this without the number line, you would take your bigger number, 7, and subtract your smaller one, and you would get what?
you would get,
3. And then you take the sign of your bigger number, so it would be a positive 3. If you didn't have a
I'm
number
just
line.
confused about that.
The number line stuff is a little bit difficult. Integers are hard. Our next one, what shape is that?
Polygon.
Well, we know it's a polygon, but what's the name of it? An octagon. How do you know it's an octagon?
Because it has 8.
It has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8 sides makes it an octagon.
Octopus has 8 on it.
Yeah, this first part, octa, means 8. Octopus, octagon, right?
The stop sign.
Or a stop sign. Yeah, stop signs have 8 sides as well. Now, vertices are the corners. How many corners are on the shape?
8.
8 again,
8.
right? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices, 8 corners. Good. Number 5, we're subtracting decimals. First thing I'm going to do is drop my decimal down so it's already there. Now, can I do 2 minus 5?
No.
No.
We need to borrow from our 6. What does the 6 become?
15 or 7
5.
or 5.
5. Carry your, and the 2 becomes a 12. What's 12 minus 5?
9 or 7.
7. Okay, and then can we do 5 minus 9?
No.
Nope,
No.
gotta borrow from the 8. What does the 8 become?
7.
7. And then this 5 becomes 15. What's
4.
15 minus 9?
6.
And 7 minus 3?
4.
4.
4. So your answer is 4 and 67 hundredths on that one. How'd you guys do overall on this?
I got them all.
All right.
Good.
Charlie?
Number 5 is kind of like number 3. Oh, yeah. Oh, good. So probably didn't even
I don't know.
Right.
Okay. Thank you. Okay, that's our warm up. Let's do the next thing. What are we doing? Notes, that's what we're doing. Okay. Let's go over to Google Classroom. We have a little bit of stuff that we're going to review, and then we'll do a little bit of practice for your assignment tomorrow that you'll do on your own.
Is that easy or tomorrow?
Yes, be at school.
Okay.
Okay. All right. So if we scroll down to math, it has not been posted yet, so I'm going to make it post. It's called graphing from tables. Can you guys see that? No. So let me get that assigned to you guys. Okay, it says that it's not working, but if you guys reload your Google Classroom, did it work?
Yeah.
You guys have one called graphing from tables? All right. So go ahead and do that. The first one we're going to open is the one where you can tell that it's a PowerPoint, graphing independent and dependent variables. You see that one? Open that one first. The other one is practice that we will do after, but we're going to start with the PowerPoint right here. Okay, so starting with the PowerPoint. There is a little bit of warm up, so we are going to kind of try it first. So, go ahead and get that opened up. I'll give you about 1 more minute. I'm going to check, make sure there's attendance. Okay, let's do it. You guys can see my screen, right? Okay. Graphing independent and dependent variables. We have been kind of building up to this. Last week we learned about what independent and dependent variables are. And then we also learned how to kind of come up with an equation based on the table that it gave us. So we're going to practice that a little bit right here on slide number 2. So go ahead and go to slide number 2, please. I'm going to zoom in on this a little bit. That wasn't very much, but I think if I go any farther, it's going to be too big. There's not text boxes here. So, oh, there's one right there. There's just not one right here. Let's add a text box to fill in this part right here. So add a text box underneath the y equals 10. This is just a warm up. We're going to talk through a few things. Make your thing a little bit bigger. So in that first one, oops. So I made a text box and added one right there. We have y equals 10x. How do I figure out what y equals if they give me x? What do I need to do? They say that x equals 1. Not add. What does 10x mean?
Subtract.
Multiply. 10 times x. So we have 10 times, I'm going to put it in parentheses. 10 times 1 is the first thing we're going to do, right? What's the next line? 10 times what? You can't see it on my screen, so you might have to be on yours. I can't see it either, so what is it? 10 times?
10.
Is it a 10? I don't know. 10 times. Good. 10 times 10. That's a 20. 10 times 10. And then finally, 10 times, what's our last one down there?
21.
21. Okay. So we have all of our things. We just need to solve now. So we plugged in our x's and we need to figure out what y equals in this case. So let's start with the first one. I'm going to make this a little bit bigger. 10 times 1 is what? 10. That's our first one. What is 10 times 10 for our second one?
100.
100. And 10 times 21?
110.
210. Yeah, so graphing independent and dependent variables are on the warm-up slide. Just kind of looking at it. You have to draw your own text box, and then you can type what I have up there. Okay. So that's how we get those answers, right? We just see what the equation is, plug in what x is, and multiply. Sometimes you'll add, sometimes you'll subtract, all the different things, right? Is there a place to type on here? Oh, there is a place to type. Good. Down below, on number 2, we're going to practice writing some equations for these tables. So our first one, we have x's and y's. The x's are 1, 2, 3, 4. Our y's are 5, 6, 7, 8. So in our first one, the first row, 1 and then 5. What are 2 ways that I can go from 1 to 5? Can I add, subtract, multiply, divide? What can I do? People, how do I go from 1 to 5? We can add how much? We can either add 4 or what? Multiply by 5. So let's start by checking multiplying by 5. Does 1 times 5 equal 5? Okay. Does 2 times 5 equal 6? No. Does 3 times 5 equal 7? No. 4 times 5, is that 8? No. So multiplying by 5 doesn't work. Let's check adding. Does 1 plus 4 equal 5? Okay, does 2 plus 4 equal 6? Yeah. 3 plus 4 is 7. And 4 plus 4 is 8. So
Yeah.
we're adding 4. How do I write that? How do I write an equation?
Y equals
Y equals what?
X, 4X.
4x means you're multiplying by 4. So how do I say I'm going to add 4 to x?
4 minus X.
Well, we're
Oh.
adding. So x plus 4. Right? We take whatever the x value is, whatever they give us, and we add 4 to it. X plus 4.
These are cool.
What are cool?
Oh, the next one's easy.
Okay, let's look at part B. Again, we're writing our equation. We need to see how we go from 0 to 0. Let's start with that. You can multiply to get to 0. We could add or we could subtract, right? So let's look at the next row because the 0 zeros don't really help. Let's look at the 1 and 5. This is the same. We could either multiply by 5 or add 4. We just did adding by 4, and does that match the same? No. So let's check the multiplying by 5. Is 0 times 5 0?
Yeah.
Is 1 times 5 5?
Yeah.
2 times 5 is 10?
Yeah.
3 times 5 is 15?
Yeah.
Okay. So our equation, we know we're multiplying by 5. You got to find the text box over there, sorry. We know we're multiplying by 5. How do I write that? Y equals, so
X.
you guys are on the right track. X times 5, but Olivia said it first, right? 5x means you're taking the number 5, multiplying it by x. 5x. Okay?
So what are we doing initially figuring out the...
We're going to learn, what are we doing? We're going to learn how to graph
I'm
them.
making equations.
No, we're going to use equations to fill out tables to make graphs.
Also, like,
They all kind of go together here on the rest of this. So we're going to go through and get working on it. I'm going to give you about, that's good. Were other people asking about it too? Other teachers then? Okay. Well, Miss Litter might not have known where it was either. Because the tech people told us that it was on the computer, but I was like, where? Log out.
log out completely, shut it down, and then you turn it back on. But before you log in, you click on the app. You get a student something.
Okay. I'll be able to find it then. All right, let's go ahead and look at slide number 3. So when you have a table like these ones where you have x values and y values, when you have a table, you can take those x and y values and put them on a coordinate plane, which I don't have it drawn up there anymore, but when we plotted the points back there for Laura and Trista and Diana, those are coordinate points with x's and y values. We can take our table and make that into a graph. So the x coordinate, like we talked about, is always your independent variable. It can change. And your y coordinate is your dependent variable. The y depends on whatever you plug in for x. Okay, so let's look at an example. I'm going to present it so that, I know you guys have it in front of you, but I'm going to present it so we do little bits, right? So Jin's car can get 24 miles per gallon. What is your independent and your dependent variable? And then we're going to complete the table and write an equation. It's a lot right there. So what is our independent variable? What can change here? The miles or the gallons? The gallons can change. The gallons. The amount of gallons that you put in your car changes. It doesn't really matter how much you put in your car. But the amount of miles that you go depends on how many gallons you have. So if you have 1 gallon, you can drive 24 miles. What about if you have 3 gallons?
You can go.
We got to figure it out, right?
Wait, you can go.
3 gallons.
72 miles.
72 miles. How did you do that?
Math.
Yes, but how? You multiplied, right? You took the number of gallons multiplied by 24. So the independent variable is gallons. The dependent is miles. We know that if we go 3 gallons or fill up 3 gallons, it's going to take us 72 miles. How do we figure out this part, this missing one? 120 miles, but how many gallons is that? Divide. Good. 120 miles divided by 24. I can see people working on that, so I'll let them finish it.
Got it. 5.
It's 5. So if we put in 5 gallons of gas in our car, it's going to make us go 120 miles. Good. So we know that we're taking our x value and multiplying it by 24. How do I write that? Y equals 24x. That's our problem, or our equation right there. So I'm going to write on the board behind me. So I talked about how we're going to take these numbers in our table and we can graph them from there. So we have our x, oh boy, I need to get new markers. X values and Y values. Our first one was 1 and 24, 3, 72, 5, and 120, correct?
Yep.
So these can become ordered pairs that we can graph. So when you write an ordered pair, it goes X, Y, correct? You guys remember this?
Yep.
So if we want to write these as ordered pairs, our X value is 1, our Y value is 24. You would go over to the right 1, up 24 on your coordinate plane. The next one, you would go over 3, up 72. The next one, you would go over 5, up 120. See how that works? You take your X value, it's your first number in your ordered pair. Your Y value is the second number in your ordered pair. And we'll practice that in a minute. Let's see what else we got here. I want to look ahead just to see. I want to make sure we have time to practice a little bit. Okay, we do on the next one. So looking at the next page, example number 1 again. Oh, because it's the same data. We took, this is what I just wrote behind me actually. We created ordered pairs out of the X's and the Y's, correct? So our first one, I think it wants you to type in there, but that's fine. Our first one was 124. So when we're looking at it, we would go over 1, because that's the amount of gallons, and up 24, and we would draw a dot right there. We graphed that point. You see how that works? The next one is over 3, up how many? 72. So we would go over to the 3, up 72. Notice that I skipped the number 2 because we don't have an order pair for that. We don't have to graph that one. Our next one was 5, 120. So we would go over 5, up 120, way up there. And there's your points. If we wanted to figure out how many gallons or miles you would get for 2 gallons, could we figure that out? How could we figure it out? We could, yeah. Or you could multiply. You were right. You could take the number 2, multiply it by 24, and you would get 48. So we could draw a dot on 48. And then for number 4, it would be at 96 because you can multiply by 4. Once you get to, I don't know if we'll do it yet. We might do it next week. I don't know for sure. But once you get to junior high, you'll be drawing a line through that. So it creates a line that goes on and on and on forever. And you can do a lot of things with that. That's what algebra is, graphing things and finding different equations and all of that stuff. Fun things.
No, it doesn't sound fun.
Let's see. Let's try another one. We're going to have to write this one out, I think. Let's see. Is this it? Example number 2. You know, it kind of already did it for us. I don't really like that. That one did it too.
Wait, we didn't answer
And that one.
the 7th one though, or the 6th one.
I know, that's okay. Okay, so you know what I think I want to do? Let me look at what this is. Okay, what I want to do is do the guided practice because that's exactly what your assignment tomorrow is going to look like when you do it on your own. So I want to do some together. So right now you have this Google Slides open, correct? You can close it. You do not need to finish filling out the stuff. That's okay. You can close out of that one. When you go back to Google Classroom, there is a Google slide there that's called Jones Graphing Independent and Dependent Variables Guided Practice. We're going to do this one together. We might get through only like 2 of them, but this is what your assignment tomorrow looks like. It's exactly the same, with different numbers. So what we do right now is exactly what you're doing tomorrow on your own. So I suggest paying attention very well on this one. These dots over here, you're going to be able to, whoa, what happened? You should be able to click on them and move them onto our graphs later, but we need to zoom in. I'm going to go, let's start with 100. 100 seems pretty good for right now. When we make the graph, we might need to go even a little bit further, honestly. But there should be text boxes for all of these spots down here for us to type into. We have a place to write our equation, and then we can move those dots to the correct spot for our graph. So let's start right here. Up in the top for number 1, what we're going to do is create the table and a graph and write an equation, all 3 things. First thing I like to do is the table, because you kind of get your equation from there. But as you're making the table, you already know what equation you're using because you have to be doing the math to figure out the stuff. So the equation kind of comes as you work on the table. So first we're going to write our x's and our y's at the top, okay? X and y, because you need to know which one is your x and which one is your y. So we know that Joe bought three hamburgers for $2.25. So is the hamburgers the x value or is the money the x? Think about it. Hamburgers are the x value. The hamburgers can change. We can put in any amount of hamburgers we want. So we're going to start by putting a 3 right there. He buys 3 hamburgers for how much money? $2.25. So that goes in our y value. $2.25 is our y value there. Okay. So that's our first one. We can figure out the rest of it from here. This is the fun part, right? I'm going to draw or do a little work behind me. How much does 1 hamburger cost? How could I figure that out? Let's find our equation. We need to figure out how much 1 hamburger costs. What do I do? Divide. Take the money for your hamburger, $2.25, divide it by the number of hamburgers that is 3. We don't need to move decimals except for to bring this one straight up. Does 3 go into 2? Nope. So we're going to put a 0 there. Does 3 go into 22? Nope. Yes. How many times? 7 times. Subtract 21 and you get 1. Drop down your 5 and you get 15. Does 3 go into 15? Nope. How many times? 5. So each hamburger costs us how much money? 75 cents, right? 75 cents per hamburger. So when we write our equation, it's the money, y, our y value, depends on how many hamburgers we buy, right? 75 cents times the number of hamburgers. 75 cents x, right?
Oh, I did it wrong. I did 60 cents.
Yeah. So each hamburger costs you 75 cents. So we can plug in our numbers that we want to get that. So our equation down here on the bottom right here is what I just wrote. Y equals, you can put 0.75 or just 0.75. It's up to you. 0.75x. I'm going to make this a little bit bigger there. There we go. Okay, so our equation, they're not going to go directly on the line. It's okay. Put it as close as you can. Okay. It's fine. Okay. So our first equation is y equals 0.75x. Right? 75 cents. That's a cheap hamburger.
I want to buy one right now.
Okay.
He bought 3 of them. He bought 3.
Maybe they're really small.
They're mini burgers.
So we have our cost per burger. Now we need to come up with a couple of ordered pairs to put on there. We already have
I know how to
3.
do it. I know how to do it. So
We get to come up with our own x values now. We could do 4, 5, 6. What do you guys want to put in there? Just try to make it within the graph. You don't want to go higher than 10. We could put in a 1. Let's do 6 maybe. Let's do 6. If you buy 6 hamburgers. How do I figure out?
6 hamburgers?
No, it's not $1. It's 75 cents for 6 hamburgers. We got to figure out how much it
What
is.
does the 1 do?
The 1 is if we bought 1 hamburger, how much would it cost?
Oh. About 75 cents.
75 cents. So we put 0.75 there. These are a little bit out of order, but that's okay. We don't have to go directly in order. How about if you buy 6 hamburgers? How much is that going to cost?
Half of 12 pounds.
Yes, it's half of 12, but you still have to figure out the cost.
I think you would do
Huh? Yeah.
Yeah.
It's not $6. They're 75 cents. You got to figure it out. Set 0.75 times 6. Not 225 times 6, because that's the cost of 3 hamburgers down. 75 cents times 6, because you're buying 6 burgers. Hmm.
Every way we could do it is 6 times 1 divided by $4.56.
You are doing a lot of work there. I don't know what you're doing.
$4.56.
It's $4.50. You take your cost of 1 burger. You just basically got to plug in 6 right there where your X is. 0.75 times 6.
Now, do we have to mark them on the graph?
We do have to mark them on the graph now. It's $4.50. So I'm going to pull 3 of these dots over here, right? And just kind of stick them over here for right now so that we have a couple. Oops.
We need just 3.
We need 3 dots, right? Okay, so there's my 3 dots. Our first ordered pair, let's see, we have 3, 2.25. So we need to take our first dot and go to the right 3, and then go up 2.25. So that's just a little bit above the 2-ish. These are really big dots, so just kind of put it as close as you can. Okay, you can make the dots smaller if you'd like to. So there's our first one. Over 3, up 2.25. The next one, you need to go over 1, up 0.75. So it's not too far up there, right?
I thought that would be in the middle of
That's not the greatest of, it's a huge dot.
That's a real big dot.
I accidentally moved the 1, so be careful when you move the stuff too. Close enough. Do your best. Close enough. Okay. What about 6? Where does that one go? How far up? How much does it cost? Nope, not 7. 6 hamburgers cost how much money? What does it say? $4.50. So we need to go over to the 6 and up to $4.50, which is a little bit in between those, right? So they should kind of go in a line as best as possible. A diagonal line, I guess you could say.
Oh, I jumped it.
Does that process make sense to you guys a little bit? A little bit. Create your table, write your equation, plot the points. We'll do one more practice and then we will be done for the day. But this is exactly what your thing looks like tomorrow. Okay, I'm going to scroll just a little bit to the right over here. Number 2. It says Sally can mow 6 lawns in 3 hours. Let's start by putting our X and our Y up here. X and Y. Okay. The number of lawns is independent. She can mow as many lawns as she wants, right? The time depends on how many lawns she mows. Yoshi, we don't need extra commentary. It's just a fake situation. So, number of lawns we're going to put as the X value because it can change. So we're going to start with 6. And then let's do 12 after that. I'm going to give you guys some X values on this. 6, 12, and 18. She's mowing a lot of lawns. Okay. Maybe she does this over a weekend. I don't know. Okay, well, don't lose it. All right. So we already know our first one. If she can mow 6 lawns, How long does it take her? What does it say in the problem?
3 hours.
3 hours. So 6 lawns takes her 3 hours. Okay. How do we figure out 12 lawns and how long that takes? How did you get 6?
Because 3 times 2 is 12, and 3 times 2 is 6.
Good, you can look at it that way. From 6 to 12, you have to double it, right? So 3 doubled is 6. Or we could write an equation here. How do I go from 6 to 3? Well, how could I do that?
Half of the track by 2.
You could either subtract 3 or
Divide 2.
divide it by 2.
Half of 6 is 3, half of 12 is 6,
Mm-hmm.
half of 18 is, I just did it by
That is true. We are dividing by 2. You're taking your x value, dividing it by 2 here. X divided by 2. Okay, x divided by 2. So y equals x divided by 2. Alex, sit down. Okay, so we are dividing by 2 on this one. What is 12 divided by 2? 6. So it takes 6 hours to mow 12 lawns.
Damn.
What about 18 divided by 2? 18 divided by 2. 9. It takes 9 hours to mow 18 lawns. Okay, I'll give you guys a minute to get caught up on that. And then we just got to plot our points on there. So if you want to pull 3 of your dots over for really quick, that's fine. Okay. I moved my 3 dots over, so let's go ahead and plot those points. Our first one is 6, 3. That's our ordered pair. We need to go over 6, up 3. How do I plot that? Where does it go? I start at this middle.
Right behind, a little bit behind, in front of the 5, and then a little bit behind the 5.
Good. So we need to go over 6 to the right, up 3, so it kind of goes in the middle-ish about right there. It's not going to be perfect. That's okay. Over 6, up 3. Next one is 12, 6. So we got to take our dot and we start at the very middle and we go over 12, which is about there, up 6, a little bit higher than the 5. Again, do your best to put it in the right spot. They're not as great as it could be. And then finally, 18, 9. So that means we need to go over 18, up 9. So over 18, up 9 is about there-ish. Close enough. Best
I
is
did mine differently,
how?
like this. I did that one there. But I did.
I think that you went up and then over. Remember, you need to go over and then up. X values first. I think you just flipped the way that you did it. Does that make sense?
Yeah.
Okay. So that's what we just did there for number 1 and 2 is exactly what you're doing on your assignment tomorrow on your own. So yeah. It'll be 6 problems just like it looks like on here. You guys will do all of them on your own. And I think it's 18 points. 3 points for each problem. 1 point for the graph, 1 point for the table, 1 point for the equation. So 3 points for each of them tomorrow. Again, you will be doing it on your own tomorrow because we have the in-person kids have some AZ merit stuff we got to do, so we cannot have live lessons tomorrow. But we still have science later today, so make sure you come to science later today, those of you that are online. No, there's more people in there. At the beginning, it was just Kaylin, but more people came on. So I'm going to stop our recording, and our live lesson is all good for the